with a strange soundtrack or something like that. So good afternoon. I am very sorry to have missed the first several days of this workshop. It sounds like it's been very exciting.
You are Santa Claus now, huh? December 6th.
December 6th?
Yeah, December 6th.
You're Dutch. For Dutch.
Ah, okay. All right, well, ho, ho, ho. And good afternoon. These slides, there's essentially no scientific content to them. These are really organizational. So I warn you that in advance. So if you want to go get another.
We can argue about that too.
And so Jorge and I were tasked with building some inelastic sessions for this workshop. And one of the things that we certainly found, well, we knew, I think, is that the definition of inelastic here is extremely broad. And it basically means anything that's not elastic, quasi-elastic, or coherent photon production. And so there's just a little bit of physics that's involved in that, really from the delta resonance all the way up into deep inelastic scattering. And all of the issues that are important for reconstructing neutrino energies, which has been pointed out in conversations that I just heard, and I'm sure in many other conversations, that because the neutrino oscillation phenomena depend on the neutrino energy, it's absolutely critical in all of the experiments, the oscillation experiments that we've defined, to make sure that we do a very good job of that. And we're often, because neutrinos don't interact very much, we're often in a position experimentally where we're using, relatively speaking, crude tools, because we need to build detectors of the scale of many kilotons, tens of kilotons, or hundreds of kilotons. And so we have to use detectors that, and we study them very carefully, but we have to use detectors that are not cannot make as precise measurements as, for example, experiments that one can do on a tabletop. So we thought hard, and actually we thought a fair amount to actually put together a single sentence like this. But basically, what is the goal from at least the inelastic part of this workshop? And that is to come out of the workshop with a program of calculations and measurements that should be made in support of understanding the theory and improving neutrino nucleus generators in order to minimize the systematic uncertainties in oscillation experiments. And these measurements, for example, and calculations are not limited to neutrino measurements. There's certainly, for example, if there are data that should be taken on for example, pion nucleus interactions, for example, that could use some extra work, that would be extremely useful. Certainly in the very early days of the generators, the problems, we're now talking, several decades ago, people did the best that they could at the time, which was to factorize these problems. And so one created a resonance in the nucleus, for example, when trying to simulate atmospheric neutrinos, and one then allowed this resonance to decay, and then one did some propagation of, for example, a pion through the nucleus until it got to the edge, in which case one would then say, well, we've successfully gotten this pion to the edge, and now we'll allow the detector simulation to take over. And people did the best that they could at the time, and they certainly tried to test those models, for example, with pion nucleus scattering data. So I think we want to look as carefully as we can at both the theory and the data that justify the particular models in the generators, and understand, for example, where can we make some better measurements over the next several years so that we can make these models the best that they can be as we move forward to try to solve very difficult problems, the problem of leptonic CP violation in particular, using in general broadband neutrino beams where we don't have a very good understanding a priori of what the neutrino energy is and what the spectra look like. So we have a very broad schedule. We'll have an overview this afternoon from Ari that we're looking forward to, and we have these are the talks today, these are the talks on Sunday, these are the talks on Monday, and this is what happens on Tuesday. And the blue is designed to represent maybe a slightly lower energy regime, and the red and a slightly higher energy regime. But we start with the theory of resonance production and decay. And this certainly, the delta is kind of the lower end of what we consider to be the space of inelastic, according to the definition. For the case of this workshop, move towards resonance production and the cascade approach to FSI. FSI here is extremely important for us because we have hadronic systems where we now need to look in more detail at what's actually going to come out of the nucleus and what actually we could potentially measure in neutrino experiments. We'll hear from Ulrich on reaction mechanisms and their influence on physics observables. We're very interested in the class talk and really what class has produced and how we may be able to employ what has happened in neutrino generators. And we'll actually have a discussion specifically on final state interactions. We'll then move into neutrino interactions in the transition region. We'll have an overview of the Coulomb-Petty model, overview of nuclear parton distribution functions, and hadronization in the nuclear medium. These, again, are very important topics for us to at least understand how little we understand at this point and where we may be able to make improvements. We have a neutrino generator roundtable, and we will be meeting later this afternoon to more fully define exactly what we expect to get out of this. I can say that one of the things that I would like to get out of this is very closely tied to this statement of the charge for this workshop, which is to understand where some calculations could be done and especially where data could be taken in the next several years to make improvements to the models that are in the generators themselves. And then we'll hear from Camilo about some recent work where there's quantitative estimates on how nuclear effects impact the measurement of oscillation parameters. So we ask speakers to try and point out areas where more theoretical or experimental results would be prudent. And we also ask the participants to be very active during this discussion, especially focused on these types of ideas. And based on what I've seen, I don't think it's going to be much of a problem. So finally, what should we produce during and after this workshop? So I'll skip this first bullet point and move on. So again, we'd like to have this list of measurements and calculations as well as a description of what the impacts on oscillation analysis are, even if these descriptions might be a little vague at this point. They're things that we can tighten up later. And we want to discuss this list along the way and summarize this in the last session and produce just a couple of page document that describes what we think to be the key calculations and measurements that should be made from here on out to help improve the generators. This is in acknowledgement that work for the very important technical work to actually, and the importance of getting more people working specifically on including these models in the generators is a very important and slightly parallel effort to this particular workshop. But here what we want to do is focus on the inputs to these generators. And we would like to turn this into a white paper with our conclusions. And the idea of the importance for that is that with some kind of document that describes what are the important measurements, what are the important calculations to make, that various collaborations, for example, that either already exist or that are in the process of being formed or could be formed to actually carry out that work, have something to point back to explain what the importance and the relevance of these calculations or these measurements are and why they need to be made, why they're important for neutrino oscillation physics, so that we don't have situations, for example, the mundane situations of various funding agencies saying, well, that's not in our mission space, we don't care about that, please go talk to these other guys, and they turn around and say, no, you should go talk to the guys who say that it's important, and the work actually ends up not getting done. We want to kind of have some kind of consolidated conclusion that a certain set of things are very important to the neutrino oscillation community. They therefore need to get done and have some place for people to point back to and say, this is why I want to do this experiment, or this is why I want to hire this postdoc so that we can carry out this calculation. So that's just all I wanted to say in terms of how we expect to spend the next several days. And I'm happy to take any questions.
ask, actually, organizationally, if you go back one. If we're trying to help motivate things, we've nicely outlined, the state of sort of the theory here and the generator roundtable. I think Camille will talk about, sort of a generic framework for looking at oscillation experiments, but isn't it useful to have people from Minerva or TDK, the running experiments, also comment on what they view as the hardest hit, the things that they're most worried about? Is that a useful thing to add here, even though I guess we don't have time?
Yeah, I think absolutely. I think hearing from Minerva, of course, would be very interesting. But I think the focus here is on the oscillation results, and so hearing from TDK, hearing from LBNE, or hearing from Nova and sorry, oh yeah, hearing from the variety of neutrino oscillation experiments is very important. Yeah, so you're absolutely right. I think that has to be done in that context. I can say, while there's been work done, there's a lot more work to, at least in the LBNE side, to really understand which measurements are the most crucial for the oscillation physics. But I think there's probably been more progress on the TDK side, for example, on that since you're running experiment.
Yeah,
Christopher, also Davide Meloni is going to also have a talk at the same time as Carino Mariani in that same session. So
Sorry.
they both looked at the effects of errors from measurements on the extracted oscillation parameters. But I think in addition, we've actually tried to reserve most of the afternoon discussions to get the input, like we were just talking about, from Minerva, about how these things can be improved and what is the analysis chain that we're going to go through to try and incorporate these results from Minerva, for example, in the oscillation pattern. So we're not asking for organized talks, but just organized thoughts at these discussions.
Yes.
Any other questions or comments for Christopher?
I have sort of a comment. Christopher, I've been here all week, and I've heard the word final state interaction used every day, and I'm still not really clear as to what people mean. I understand it's subsequent to what happens after the weak vertex takes place in some nucleus, but I have no idea of how completely one wants to extend that final state interaction. Is it to go till the last neutron trickles out of whatever the nucleus is, or do you just want to know what happens to particles that have energy more than 10 MeV, more than 20 MeV, more than 50 MeV? That would be really useful, I think, for me to understand, and I would think for the theorists to get a sense. So.
Okay. That's an interesting question. Of course, in an ideal world, you'd like to do the former. You'd like to just get everything, but that's clearly there's a question about how there's clearly a question about how tractable that problem is. I guess I would phrase it instead of having a specific and this may translate into a specific, for example, kinetic energy cutoff of baryons and being emitted from, or boiling off of the nucleus even, is that we need to understand the neutrino energy as best we can. And so the question is how much energy is actually dumped into that system, and how much do we actually get to measure? And certainly if you have a 5 GeV neutrino interaction, worrying about a 10 MeV kinetic energy neutron is not at the top of the list of priorities. But sorry?
I can give you a counterexample.
Okay, yeah, please.
Yeah, so just in, for example, Super K right now, there is a development of basically neutron tagging through neutron capture on the free protons. There's a possibility of outside gadolinium. And so in principle, we can do a neutron counting after the neutrino interaction, in which case it doesn't matter what kinetic energy came out, right? 2 MeV or 10 MeV or like 1 GeV, those will eventually thermalize and undergo capture. And so then we the threshold for that is zero effectively.
So, but then the question there might be slightly different in the sense that you might care about, multiplicity of hadrons. And if the total energy is below a certain amount, but you can talk intelligently about the multiplicity, that would certainly be useful.
Jorge has comments?
Yeah, I think, Christopher, that's also gonna be an interesting topic for the generator roundtable, right? Because if it's gonna take a day to produce an event, this is obviously something that we can't do. So we have to also hear from the generator people, what is an effective cutoff as far as their generating events?
No, but
That's true.
that doesn't really matter. I mean, for the generators, it doesn't matter in terms of computing time if you produce a 5 MeV particle or a 500 or a 5 GeV particle at the end, you know, that doesn't matter. You just run the thing indeed to the end, and then you look at it. And for the energy reconstruction that you mentioned, I mean, that's of course essential. Even if you have low energy particles there, let's say only 50 MeV, but if there are 10 of them, then that's already 500 MeV, you know, so
Yeah.
One better be careful on that.
That's right. And I certainly meant to say, if I didn't say, that what we care about is the energy of the whole system.
Yeah.
You know, how much, that's why I tried to phrase it as if Jerry was asking that there's not a specific kinetic energy cutoff at the end, but you certainly want to know, since you want to calculate the neutrino energy, that you really need to, know final state interactions up to the last, percent of the total neutrino
And
energy.
since your detectors naturally have some sort of thresholds, and then you want to know how much you are losing because of
That's
those
right.
thresholds.
Exactly. That's right.
And then there's the neutral particles.
Yeah.
Yes.
That's the real sticker.
Yes.
You don't know how much is charged versus neutral. And so you have to use the Monte Carlo to tell you how much is neutral that you couldn't see, how much is below threshold you couldn't see. And in calorimetry, you're trying to account for various things. It's a very, very tricky business.
Yes.
And we can't underestimate the trickiness of it, I think. It's going to take a long time to sort out.
Any other comments? We don't have to have the roundtable literally right now, but we can already tell it's gonna be an interesting conversation over the course of the next couple of days. Any final comments or questions for Christopher and Jorge before we go along? Okay, if not, let's thank Christopher.